pre-processing, features section, and many other things. So we start with the introduction of BPB publications. BPB is Asia's largest publishers of information technology books, and for the past 63 years, BPB has been a friend, philosopher, and guide for programmers, developers, IT professionals who have made things happen in the IT world. It was started by Shri G.C. Jainji, who has been honored with the Padam Shri Award in 2002 by Honorable President of India for his contribution in spreading IT education in the country. So we have published over 5,000 titles from the world-class authors and sold over 90 million copies worldwide. So it's a great honor and pleasure to invite the speaker, Mr. Harsh Bhasin, who worked as assistant professor in Jamia Hamdard and guest faculty in various institutes, including Delhi Technological University. He is the applied machine learning researcher. Mr. Harsh is the author of our book, Machine Learning for Beginners by BPB Publications. So, welcome, Harshji. We are very happy to have you here. Harshji, please share your knowledge with the participants and over to you. Please start the session. Thank you so much.
Thanks a lot for the introduction.
Yeah, thank you.
Uh, so, not able to share the screen.
I'll just start with
Fine. Fine. So, good afternoon, friends. I'm Harsh Bhasin, and I would like to welcome
Good afternoon, sir.
you. Uh, the webinar is on the fundamentals and implementation of machine learning. Uh, we all know that machine learning is changing the world and it will continue to do so in the near future. And the demand for AI skills has also been increasing. The number of people working for ML is much greater now. We all know this. Now, most of you must be knowing Andrew Zenji. He's a professor at Stanford and is a co-founder of Coursera. And as per Andrew, AI is the new electricity. As in, it will transform every industry and create huge economic values like electricity did a century ago. Now, as per Forbes, ML and DL will be the two of the top 10 most popular tech skills in the coming years. So this is the reason why one should learn machine learning. Now, today I would like to throw some light on the following topics. We'll start with the introduction to ML, its definition, applications, classification, the pipeline of ML, and we'll give a brief introduction of deep learning, and finally we'll conclude. Now, ML is used in recommendation systems. So if you create an Amazon account and buy some items, this will lure you into buying some more items. It somehow knows the type of t-shirts I'm likely to buy. It knows I love headphones and books, and it can even recommend comics, which a rule-based system will not do to a middle-aged man. Now, ML is also used in autocomplete of Google and even in your handsets. Now, ML is also used in natural language processing. So detecting a trigger word and understanding what you are saying are done using deep learning and machine learning. Even the face detection system of Facebook, machine learning is used. Machine learning is also used in the detection and prediction of diseases. So this is something which I do. I'm a computational neurologist. So towards the end of this presentation, I'll tell you what I exactly do. Finally, ML is now being used in customer care as well. So it is possible that you might be talking to an ML system and not to a human being when you're making a call to a customer care center. Now, let's come to the definition of machine learning. The person that you see in this picture is Arthur Lee Samuel, who was an American pioneer in the field of computer gaming and artificial intelligence. So, as per Arthur, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. There's another popular definition of machine learning, which was given by Tom M. Mitchell. So when the performance measure P on the task T increases with the experience E, the system is set to learn. Now E here is the data, and this is the difference between a conventional system and a machine learning system. So in a machine learning system, you expect your learning system to learn from the data and not the rule-based system. Now you want it to do something, which is the task. Task can be supervised. Supervised task is one which uses data and labels. And task can also be unsupervised, which doesn't contain any labels. So we'll talk a bit more about supervised and unsupervised learning later on. Now, there are two more types of learning. They are semi-supervised and reinforced learning. Now, as far as semi-supervised learning is concerned, it's an approach which uses some amount of labeled data and a large amount of unlabeled data. Now, examples of supervised learning are classification and regression. Examples of unsupervised learning are clustering. Example of semi-supervised learning we'll see later. So again, once you develop a system, the most important thing is the performance of the system. It's important that you measure while delivering the system, you are sure about the performance of your system. The performance of a classification system can be measured using accuracy, specificity, sensitivity, and F measure. That of regression can be measured using root mean square. Now, as far as this definition is concerned, when the performance measure P on task T increases with the experience C, the system is set to learn. This definition, as I told you, was given by Tom M. Mitchell. Now, Andrew, in one of his lectures, stated that he asked Tom whether he created this definition because of times, and just for the record, Tom didn't answer affirmatively. Now, let's just have a look at the pipeline of the machine learning system. Now, we start the process with pre-processing. So pre-processing is data specific. Data specific as in I work in structural magnetic resonance imaging data. So the pre-processing is quite exhaustive. If you are working in images, your pre-processing can be different. The pre-processing of sound can be different, and so on and so forth. This is followed by feature extraction. Now, feature extraction is also modality specific. We can use Fourier transform, HOG, so on and so forth for feature extraction. Then we use feature selection. We'll talk about these things later on also. Then we move to feature selection. Feature selection can be done, say for that matter, using FDR, feature discriminant ratio. And then we come to classification, regression, so on and so forth. Now, this is followed by evaluation and post-processing. Post-processing as in, I told you that I work in structural magnetic resonance imaging data. So after we have applied machine learning to our data, we generally tell the region to which that particular discrepancy belongs. So it can be one of the things that you do in post-processing. Again, so this picture shows the complete pipeline. As you can see, we have pre-processing, feature extraction, feature selection, task, and then evaluation and post-processing. Now, as stated earlier, feature extraction depends on the modality. Some of the techniques for feature extraction are as follows. For the images, we use Fourier transform, short-term Fourier transform, histogram of oriented gradients, local binary pattern, discrete wavelength transform, and so on and so forth. For sound, Fourier transform, short-term Fourier transform, and so on and so forth can be used. For numeric data, we can use first-order features, second-order features, principal component analysis, and for text, we can use embeddings. Now, there are many other feature extraction methods, and obviously, a feature extraction method will depend on the data. Now, there are many tools available for classification in machine learning. They can be logistic regression, k-nearest neighbor, naive Bayesian, single layer perceptron, multi-layer perceptron, support vector machine, and decision trees. Now, one thing that you need to keep in mind is that you don't start with support vector machine. If suppose you have lesser data and you can do your work using logistic regression, then don't go to support vector machine. This is one of the most important things that you must keep in mind. Furthermore, unsupervised learning can be like there are many tools available for unsupervised learning, primarily for clustering, for example, k-means, spectral clustering, hierarchical clustering, and so on and so forth. Now, before coming to deep learning, we must understand that we need to understand single layer perceptron and multi-layer perceptron. We need to understand their advantages and need to understand when we cannot use them. As far as deep learning is concerned, it's in. It is a buzzword, but we must remember that we cannot use deep learning if we don't have requisite data. Furthermore, we cannot use deep learning uh, if we don't have similar type of data, if we don't have that much computing power, because deep learning is effectively a bigger neural network. So that neural network, as in the activations of that neural network, uh, for example, the way we calculate the features and so on and so forth, they largely vary. But the point is, deep learning is a bigger neural network. So in order to train a deep learning network, either you need a data which is similar to your data, or you need to have a large amount of data. So you don't just jump to deep learning. First of all, see if you can do your work using machine learning, using conventional classification regression algorithms, tune your model, and if you have sufficient amount of data, if you have sufficient amount of computing power, then you move to deep learning. Now, in many of my webinars, people ask me what are the prerequisites of as in machine learning. So, to which my answer is probability, linear algebra, and basic programming. Basic programming, I prefer Python, but one can also use R or Octave or MATLAB as is as in as you deem fit. So, this is my book on machine learning. It has been published by BPB. So the book includes data preprocessing. It has some of the assorted methods like feature extraction. Division of data into train and test set has been explained in detail. And the book explains each algorithm and also discusses some derivations in mathematical modeling. Implementation from scratch of most of the algorithms has been included in the book. So it's not the case that the book only talks about sklearn or the inbuilt functions. The book explains how to make, for that matter, a single layer perceptron, how to create your own multi-layer perceptron, and so on and so forth, how to discretize the data, how to implement k-fold by yourself, and so on and so forth. So algorithms have been analyzed using various data sets. Uh, this is one thing that you must also do if you develop if you develop a machine learning model. You must make sure that your machine learning model performs well on the not just on the trained data, not just on the validation set, but also on the test set. So it must generalize well. So please take care of overfitting while developing a machine learning model. Now, I believe that the reader will be able to understand the types of learning after reading this book, implement learning algorithms from scratch, use sklearn to implement algorithms, analyze the algorithms on various data sets, and use various feature extraction and feature selection methods. Now, this book is designed for undergraduate and postgraduate students of computer science and for the professionals who intend to switch from the fascinating world to the fascinating world of machine learning. This book requires a basic know-how of programming fundamentals in general and Python in particular. The book also requires a basic knowledge of linear algebra and calculus. Now, in the beginning, I told you that I work on mild cognitive impairments, as in I work on the detection of diseases. So this is one of the fascinating branches of machine learning. So what we do is we work like we have SMRI data and we try to predict whether a person is going to have Alzheimer's or not. So this is interesting. So I'll tell you what is mild cognitive impairment. Mild cognitive impairment is a condition characterized by significant cognitive impairment in the absence of dementia. So it means that if a person is having mild cognitive impairment, he may not have dementia. So MCI affect cognitive abilities, but not to not significantly enough to hamper the daily activities. And as per studies, 15 to 20% of the persons suffering from MCI develop dementia. So this is the reason why the detection of MCI at earlier stage will help the patient. It's considered as a prodromal phase of dementia, especially of the AD type, Alzheimer's type. Now, people suffering from mild cognitive impairment faces a lot of problem. They faces problem with visual perception, with communication, with poor judgment, with misplacing things, and so on and so forth. So it will be better to detect MCI at an earlier stage. So this is where machine learning comes into play. Machine learning actually helps us to uh, like develop systems which will help us to detect diseases at earlier stages, to stop the progression of diseases, and so on and so forth. So having said this, I'll go back to the, the types of machine learning. I told you that we have many types of tasks in machine learning: the supervised task, the unsupervised task, and the semi-supervised task. Now, examples of supervised tasks are classification. So classification as in supervised task has data and labels. So I'll just give you an example. If suppose you are having your pictures and your friend's pictures, and you put label on your pictures and your friend's label. For example, all your pictures are labeled as one and labeled with ones, and all your friends' pictures are labeled as zeros. So if suppose you intend to develop a system which can classify your picture and your friend's picture, then it's an example of classification. So its classification comes under supervised learning because you give labels to the system. Likewise, as far as unsupervised learning is concerned, you don't have any labels. So suppose you have a large amount of data and you need to group them, then then unsupervised learning comes into play. Now, as far as reinforcement learning is concerned, uh, reinforcement learning is interesting for automated vehicles, for helicopters that can fly themselves. Reinforcement learning is required. So, what is reinforcement learning? Reinforcement learning is uh, the way you teach a dog. For example, if suppose you intend to train a dog, and say for that matter, the dog behaves as per your expectations, then you say that you are a good dog, and say for that matter, you provide some things to the dogs, uh, for example, biscuits and so on and so forth. And if the dog doesn't behave as per your wishes, then you say you are a bad dog. Likewise, in reinforcement learning, if suppose the system performs in the expected way, then we say as in we create a loss function which tells the system that you are performing well. If suppose the system doesn't perform well, then the loss function tells the system that you are not performing well. So for automated tasks, this reinforcement learning is being used. Now, as far as regression is concerned, regression is like predicting weather, predicting the price of a house, and so on and so forth. So for prediction, when the label is not uh, discrete, the label is a real number, then we use regression. Now there are many tools available for classification and regression in sklearn. However, in my book, I've made sure that I've implemented most of the tools from scratch. So while reading the book, I would encourage you to kindly have a look at the implementations and don't just copy the implementation. Try to have a look at the implementation, implement it by yourself. Once you have implemented the system, then just compare its performance with the inbuilt functions of sklearn, and most of the systems will perform well, as good as the sklearn's implementations. Now, as far as unsupervised learning is concerned, as far as clustering is concerned, uh, like if suppose you are employed by, say for that matter, a political party to find out the voters who have not made their mind, then you can use this particular thing in order to identify those voters. So clustering is basically grouping people. So in grouping people, we don't have labels initially. So therefore, it comes under the view of unsupervised learning. Now, in tasks like prediction and disease progression, semi-supervised learning comes into play. And as I told you, that reinforcement learning is also important. Now, and we come back to a feature extraction and feature selection thing. Now, in the book, most of the like some of the uh, implementations are given as far as feature extraction is concerned. And you must keep in mind that a particular feature extraction may work from one for one data set. It may not work for the other data set. However, uh, there has to be a strategy while extracting features. For example, if suppose you are working in images, then you will use some of the feature extraction methods. For example, you can start with local binary pattern because local binary pattern will give you LPV. This LPV will give you all the orientations. Uh, if you can if you can combine it with DWT, discrete wavelet transform, then probably you will get better features. Why is it important to find out features? Is because the imaging data or the video data, like you cannot use the raw imaging or the video data for the purpose of classification because it will contain a lot of features. So with limited data, you cannot learn so many things. So this is the reason why feature extraction is important. Now, feature extraction can also be done by Fourier transform, short-term Fourier transforms, but it will be better to start with HOG and LPV. There are many other feature extraction methods. Now, as far as sound is concerned, there are many in sound you will not use the same feature extraction methods as used in images. So probably you can use STFT and so on and so forth. That is short-term Fourier transform. Um, as far as numeric data is concerned, in numeric data, principal component analysis works very well. So in the book, principal component analysis has been implemented, and you can also use the inbuilt function of sklearn for principal component analysis. Now, it's important to understand how these feature extraction methods work. In understanding how these feature extraction methods work, you must also appreciate the math behind these methods. Now, I've made sure that I've included all the derivations in the book. I've included the implementations in the book. So it's important important for you to know the math behind these methods so that you can justify their applications in your data. Like some people present here are working in text data, and uh, in as far as embeddings is concerned, like you can use different types of embeddings and you can also learn embeddings from the data. That depends on how much data do you have. So uh, as I told you earlier that we have many algorithms for classification, I would not like to like you to start with the most complicated one. I would like you to start with the least complicated one, the simplest one. For example, logistic regression. Uh, this is because of Occam's razor. Like, if we can do our work in like using lesser memory and in lesser computation time, then we must not use a complex algorithm for doing the same task. Same is the case with unsupervised learning. You can start with spectral clustering, but see if you can do your task with k-means. So if you are able to do your task with k-means, don't use spectral clustering. Hierarchical is good. So again, uh, I would like you to implement all the algorithms, see which works best for your data. And once you've seen which works best for your data, you can explore other algorithms as well. So as far as deep learning is concerned, this book, my book is for machine learning. Uh, as I told you earlier that I suggest starting with machine learning, fundamentals of machine learning, probably doing machine learning for some time, taking some of the projects, performing well in those projects, then start with deep learning. Don't start with deep learning right away, because otherwise you'll think that it is something in which we can give the data and it gives the output. You might not understand the mathematics behind it. You might not appreciate the mechanism of deep learning. So what I would suggest is start with neural networks, start with single layer perceptron and multi layer perceptrons, and then move to deep learning. Now, As far as prerequisites are concerned, I told you what are the prerequisites of this particular subject. Now, I may also add that you might have done probability earlier, you might have done linear algebra earlier, and you might have done basic programming earlier. However, even if you have not done linear algebra, then you can go through the basics of linear algebra, particularly eigenvalues and eigenvectors. Matrix multiplication, eigenvalues, and eigenvectors are the three most important things that you must be knowing before starting machine learning. Likewise, as far as probability is concerned, it will be good to know the concepts of conditional probability before starting off with machine learning. Now, as far as programming is concerned, I like Python. Um, I do my work in Python. Earlier, I was doing all my projects in MATLAB, but as you know, that Python is free and it performs well. Actually, Python it's easy, it is efficient, it is effective. As in, I like Python, so I do my programs in like I do my I can make my systems in Python. However, some people also work in R or Octave, and they also do well. So it actually depends on you. As far as the book is concerned, all the implementations are given in Python. So, um, like as far as the book is concerned, I told you about the features of key features of this book. I also told you about like the objectives, as in what you'll be learning and what you'll not be learning, and the target audience of this book. However, I would like to add a few things. Now, one of the appendix of this book contains a project on face recognition, as in face classification rather. So what you can do is you can start with that project, try various feature extraction and selection methods, try their combination, see what works well, and then decide your own pipeline. Let's come back to pipeline. So, like while doing a machine learning project, please don't think that if you have applied classification or regression, then your work is over. Please make sure that you do the pre-processing followed by feature extraction. Now, why feature selection is important, I'll tell you. Now, some of the features that you have extracted using feature extraction might not be relevant. And it is possible that some of the features are correlated. It is possible that some of the features are redundant. It is possible that some of the features may contain noise. And this is the reason why feature selection is important. So please make sure that you start with pre-processing, uh, followed by feature extraction, followed by feature selection, then move to your tasks, for example, classification and regression. And after doing your task, acha, one more thing. Now, for for a person like me, division of data into train and test set is also very important. So this book talks about division of data into train and test set, and this book tells you how to implement train test set, as in how to implement k-fold, how to implement train test set, and why k-fold is better. Now, if you're doing a machine learning project, please remember that it's not necessary that you should declare that my training accuracy is 99% or 98%. As a matter of fact, if your training accuracy is 100%, there must be something wrong in your model. As far as machine learning model is concerned, I'm not talking about deep learning. So, okay, what should happen is that your model should work well with the unseen data, with the test data. So, if suppose you are using train test set and you are getting a very good accuracy in the training, please repeat the process many times or else use k-fold. So this book talks about k-fold. This book tells you about the implementation of k-fold, and this book tells you why k-fold is important, why you should divide your data, and what makes the division of data the most important thing in machine learning. Because if suppose you develop a model by develop a model in 3 or 4 months, you like give that model to your customer, and you like the accuracy which you are getting with the test data is pretty different from what you are getting during training or while validation, then your model is actually is not of much use. So it's better to spend some time on the classification, as in on the division of data into train and test set as well. Now, let me just come back to machine learning. So we've talked about the technicalities of machine learning. We've talked about the definition of machine learning. I told you that why machine learning is important. Uh, it, it is going to provide you with many opportunities. And like I told you about all these things. I told you that many important people consider that it is the new electricity. Many people say that if suppose you are good in machine learning or deep learning, then you will get a good job. I told you that there are many applications of machine learning. Now, let's just come back to the applications part. Some of you might be interested in gaming. Machine learning is being extensively used in gaming as well. Now, as far as machine learning is concerned, uh, one of the most important things that you learn, for example, I told you about Alexa. Alexa uses natural language processing. Disease classification, I told you about my work. I am using machine learning for the prediction, conversion prediction, and classification of mild cognitive impairments from Alzheimer's. As in, I'm trying to detect whether a person will have Alzheimer's after some time or not. Likewise, face detection. You often see face detection in Facebook. You use YouTube, you use Amazon, and you understand that recommendation systems actually work very well. Now, there's something interesting in machine learning. I think the most interesting part of machine learning is neural networks. Now, neural networks is actually beautiful, and neural network is something very exciting. So, like for example, let's talk about Alexa. So, I think that some of you might have seen Friends, and you might remember Smelly Cat. So, I like Friends and I like music. So, whenever I think about Friends, Smelly Cat comes to my mind. When I see Big Bang Theory, Soft Kitty comes to my mind. When I see Mowgli, Jungle Jungle comes to my mind. So, like, like your mind drenches your thoughts with the melodious voices and take you deep down, landing on the compositions by Faz. And this is the similarity between Alexa and your mind. So while growing up, you listen to songs, memorize them, associate them with situations, characters, cartoons, and so on. And your mind becoming a jukebox is an outcome of this process. Now, neural networks also work in a similar way. And things like Alexa, recommendation systems, they use learning systems like neural network. They are inspired by the neurons in the brain, which are the most important and perhaps the most complex organ of the body. And you understand that mind acts as a central processing unit of computer, like of our body. Uh, so neural networks are inspired from the working of neurons. So chapter number 5 and 6 of this book extensively talk about neural networks and their implementations. And I told you that I've made sure that the implementations are given from scratch, as in uh, I've not just used sklearn for implementing most of the things. I've explained the reason behind using a particular activation function, the implementations of those activation functions, the effect of variations of data sets and activation functions, and so on and so forth. So I think that while reading the book, you'll enjoy implementing most of the systems and using those systems for your tasks. Second thing is that if suppose you are working on a machine learning project, there like you'll face many problems. You'll face many problems, as in starting from the pre-processing to the selection of, say for that matter, the classifier. You'll face many problems. It is quite possible that you might not even get relevant features while classifying some of the, say for that matter, you're trying to classify trying to classify two SMRI images of controls and Alzheimer patients. It's important to find out relevant features in order to do so, because generally you have limited data. Now, you must understand that, as I told you earlier, that machine learning is not something in which you put data and it gives you answer. You must appreciate the importance of this pipeline. You must appreciate the pre-processing techniques, the feature extraction techniques, the feature selection techniques, the mathematics behind classification and regression, the importance of post-processing before starting your work. First point. Second point, that it's not important to declare that you're getting 99-100% accuracy. Your system must perform well with the test data. Third point, that you need to find out the optimal combination of feature extraction and feature selection methods. You need to see which classification works well for your particular data, which algorithm works well for the pre-processing of this particular data, and so on and so forth. Now, what I've done is I've made a Facebook page with the same name, that is Machine Learning for Beginners. I'll make sure that I put some of the projects on the Facebook page as well. If suppose you find something which needs to be changed in the book, which needs to be added in the book, you're most welcome to give suggestions. And I hope that we'll be able to come up with better editions in the near future. And you're most welcome to ask any questions if you want. Now I'll leave you with one thought. Never say after 6 months, after 7 months, when you have done machine learning, when you have done some of the courses, when you work on some of the projects, then please don't say that you have become an expert in machine learning. Be a learner, not a knower. This is what is important. So start with machine learning. Try to do as many projects as you can. And remember one thing, that we need to learn. We need to learn as and when we grow. It's never a case that we know everything of not to talk about machine learning. Even if you're working in algorithm analysis and design, I don't think that there's a stage when you can say that I know everything of algorithms. Likewise, at this point in time, there is absolutely no point saying that you know everything of machine learning. Start with machine learning, start knowing, start learning, and become better. So, I would like to thank BVP for publishing this book. And if suppose you have, if any of the questions, any of you have any questions, you're most welcome, ma'am.
Yes, Harsh, thank you so much. I think we can take questions now.
Sure.
Any question in the chat box?
Okay.
Good afternoon, sir.
Good afternoon, Jay.
Sir, can we get the recording of this on our email?
So I think Ankita ma'am will put the recording on YouTube, I suppose. Am I right, ma'am?
Yes, please. Yes, please.
Right.
Thank you, sir.
You're welcome. So I think there's a question in
From Dev Pratap Singh. Yeah.
Okay. So Dev, what is the question? How is AI different from ML? Okay. So machine learning is a part of artificial intelligence. Those of you who've studied artificial intelligence, well and good. If you have not studied artificial intelligence, you can straight away start with machine learning. So machine learning is like, when I say that AI is in the air, it's actually machine learning. I told you about Alexa, I told you about recommendation systems. So each one of them uses machine learning. So machine learning is a part of AI, which primarily is based on instance-based learning. So you give samples and you give the output, and the system learns. So artificial intelligence is a broader topic which has many theories, which has which tells you about many theories of learning, which tells you about planning and so on and so forth. So if suppose someone is working in robotics, then he needs to know about AI in general. So if you are working in any of the systems that I told you, then starting with machine learning is it'll be good. Okay. So any other question? Acha. So
different types of ML. from
Okay,
Shelly
fine. So
Batra.
different types of ML. So in the presentation, I'll share the presentation again. So I told you that we have, okay. Okay, we have many type of tasks in machine learning. So for example, we have supervised, unsupervised, semi-supervised, and reinforcement learnings. So if suppose uh, you are working on the detection of faces, then it comes under supervised learning because you will tell the system that this is a face and this is not a face. If suppose you are grouping people and you're not knowing the labels, for example, I told you, suppose you are employed by a political party to find out the voters who have not decided their mind. So you may use some feature extraction selection method. So if you are working on unlabeled data, then it is unsupervised learning. Likewise, if you have lesser amount of labeled data and a large amount of unlabeled data, then it is semi-supervised learning. And if suppose you are working on, say for that matter, autonomous cars, uh, robotics, and so on and so forth, then reinforcement learning works very well. In reinforcement learning, we develop a system, we develop a loss function, which tells the system whether the system is working well or not. Okay. So can you like what's the next question?
Can we develop an AI system without ML from Shalu Ahuja?
Acha, so Shalu Ahuja, actually I told you that implementation, like ML talks about, like ML deals with the implementation of AI. So if suppose you are talking about an AI system, what type of AI system are you talking about? If you are talking about natural language processing, it's done by ML and DL. If you are talking about recommendation system, it uses ML. If you're talking about any such system, then it actually uses machine learning. So AI, acha, ek minute, matlab, there's a small point here. So there's a series called Silicon Valley. In Silicon Valley, they develop a system using symbolic learning. So I've not seen symbolic learning in use as of now in any of the companies. So if let's start learning machine learning, start deep learning, it is quite possible that you may come up with a system that uses symbolic learning. What's the next question?
Okay, thank you. So, from Ashutosh Tiwari, for face detection, which is better, machine learning or deep learning?
So, Ashutosh, as far as face detection is concerned, now we have sufficient amount of data and therefore we can use deep learning. If you don't have sufficient amount of data, then machine learning is better. Furthermore, if suppose you are working, you are suppose intending to develop a system, then you can use the data of some of the previous years challenges in order to train your deep learning systems. I'll tell you one more thing. For for face detection, actually these conventional methods, for example, single layer perceptron, multi-layer perceptron, feature extraction, feature selection, will work, but convolution neural networks will work in a better way. So start with machine learning, move to deep learning, uh, like uh, like start with convolution neural networks, and convolution neural networks will work as in they'll work fantastically as far as face detection is concerned.
Yeah, thank you so much. So I think we can take a question from Harmeet that can you walk us through one simple example of selection of any machine learning algorithm and why did you go for it? So she wants to know.
Definitely I can. Definitely I can. So just 1 minute. I'll just 1 minute. Okay. So ठीक है. So this is one of my papers which has been recently published. It is in BMC Medical Informatics. It's an SCI journal with decent impact factor. Now, what we have done is we have we've classified MCI converts from MCI non-converts, as in the patients who converted to Alzheimer's and the patients who did not convert to Alzheimer's. We have used structural magnetic resonance imaging data. So we have used structural magnetic resonance imaging data, and we've got the data from Alzheimer's Disease Neuroimaging Initiative. This paper is available. You can access this paper. This paper is open access. So first of all, we did pre-processing. As some of you might be knowing that for pre-processing structural magnetic resonance imaging data, we need slice time correction, head motion correction, spatial normalization, spatial smoothing, tissue segmentation, and so on. So this was followed by feature extraction. The feature extraction was done using 3D discrete wavelet transform. So this is an existing method, and we proposed a new feature extraction method. So that was 3D LPB. So 2D LPB is already known. We proposed a new feature extraction method that was 3D LPB. We combined these two methods, and we judged the performance of our system using three measures: accuracy, specificity, and sensitivity. Now we were able to get good results. This is the model, and as you can see that this method works well for the classification of other data sets as well. So what we have done is, I'll just show you a few tables. Okay, I'll just show you a few tables. So what we have done is we actually constructed 5 different models, and we tested these 5 models on 2 different data sets. So this combination works well for both the data sets, and amongst 5 different proposed models, this model works well. So this is an end-to-end pipeline, as in starting from the pre-processing part to feature extraction part. Feature selection has been done using FDR. FDR is given in the book. So after that, we have used support vector machine for classification. So this is an example of end-to-end machine learning, and this paper is also available. So next question.
Thank you so much. So I think we can take a question from Mr. Joseph. There's a question from Mr. Joseph. Just a second, please. What all languages come under AI and ML?
Okay, so Mr. Joseph, actually the point is that in order to start ML, you must know either Python or R or MATLAB, though you can develop systems using conventional languages like Java and C# and C also. But the point is that if suppose you are knowing these languages, these languages also contain some of the libraries which will help you to develop systems in much faster, as in more efficiently and using lesser space. So you can either choose Python or R or Octave or even MATLAB. MATLAB I was working earlier. As far as I am concerned, I told you that I like Python, so go for Python.
Okay. There is a message from Shailendra that will you please define matrix again?
Sure, definitely. So which type of matrix, do you want me to define, sir? As in for evaluation purposes? Mr. Shailendra?
Yes, sir. Yes, sir. Yes, sir.
Yes.
Okay, fine. Okay. So, Mr. Shailendra, as far as classification is concerned, please keep one thing in mind, that just 1 minute. Stop presenting. Okay. Tab. So I think you are able to see the Chrome tab. Fine. So as far as matrices are concerned, matrices are different for classification, for regression, for clustering, and so on and so forth. As far as classification is concerned, we all know what is accuracy. Accuracy is our system. System is able to identify some of the labels, and how many of those labels are correct is called accuracy. But accuracy we cannot use accuracy every time. For example, if suppose you are developing a spam classifier, then we understand that most of the mails are spam. So even if your classifier comes up with 90% accuracy, it actually means that your classifier is not working well, because it is quite possible that your classifier is classifying all the mails as spam. So along with accuracy, you can use specificity, sensitivity. Specificity is the number of true positives. Up from true positive divided by true positive plus false negative. So this is sensitivity. Specificity is true negative divided by true positive plus false positive. And likewise, you can also use sensitivity and specificity's harmonic ratio, which is F measure. So except for these measures, you also have precision and recall as far as classification is concerned. For regression purposes, you can use RMSE, as I told you. Next question, please.
I think there is no question now. There's a message from Mr. Joseph. He liked the answer and it was a great answer, very useful. A message from Hermeet. Can you please share the link to this paper? It would be of great help.
Sure. I'll just right away share the link to this paper.
Yeah. So thank you so much, Harshji.
You're welcome,
So let's close the session.
Sure, definitely.
Sorry. There is a message. That question from Ashutosh Tiwari is not answered. Let me check. Ashutosh Tiwari. What is the best technology currently running for face detection? Currently, he's working with YOLO. So he wants to know the name of the technology which is used for.
So as far as face detection is concerned, you are using YOLO, which is good. YOLO works very well for face detection, and you must be using CNNs. So what you can do is that for sure you are using CNN, for sure you are using YOLO. Don't change YOLO, just make some changes in the CNN wala part. So what you can do is you can try different activation functions. So what we did was, you must be using a ReLU activation function. So what we did in one of our projects was that we used some unconventional activation functions clubbed together with conventional activation functions, which improved the accuracy to a great extent. So what you can do is you can use combination of activation functions. Don't change YOLO. YOLO works very well. Just change the type in which activation is transferred from one layer to another. Your system will definitely work well.
Okay, Harshi, thank you so much.
You're welcome, ma'am.
So let's close the session. And it was really great. And thank you so much for all your efforts. It was a very informative course.
Thank you, ma'am.
So we would also like to thank our dear participants for all their support. And we are sure that this knowledge and session has developed more awareness and learning experience. So, and we would also like to share that we have best books in machine learning, which covers the important concepts and topics in machine learning, like machine learning for beginners, machine learning with Python, and machine learning with deep learning algorithms. So these books are designed for undergraduate and postgraduate computer science students and for the professionals who basically want to switch to this world of machine learning. So all these books are available at bpbonline.com, and we hope that everyone benefited from this webinar. So all other queries left will be answered after the webinar. So thank you so much. Thanks, Harshi. Thanks once again. Thanks all the participants. Thank you so much. Thank you.
Thank you.